Hey everyone. So today we're going to start a new unit, and I want to kind of unpack the concept of what the slope of a line is. Now, the nice thing about this is really this is where we left off on the last unit. The last thing we talked about in relations and functions was this concept of rate of change. And how we got rate of change is we looked at the change in the y's, or the change in the dependent, and then we divided it by the change in the independent, or the change in x. That is slope, okay? There is no difference between the rate of change and slope, except one tiny difference. When we're talking about rate of change, we're usually referring to units with that number. And when we talk about slope, there are no units with it. It's just a number, okay? But how we develop it is still going to be the exact same way. We figure out what the change in y is, and we divide it by what we have figured out the change in x is. Now, that lends itself to a formula, and what I want to do is take some time to actually build that formula with you. So that's where we're going to start this morning. So, Cartesian plane, first of all, quick little review, also known as the coordinate plane. It's created by René Descartes and used to plot two-dimensional data. So you'll see here we have two labeled axes. The horizontal is called the x, so that's this guy here. And then the vertical is called the y, that's this guy here. Each axis goes in a set scale. Now the scale doesn't have to be the same for x and y. The x's could go up by 2s as a scale, and the y's could go up by 100s as a scale. But whatever it is, there has to be set increments, okay? So there has to be some sort of a grid that's formed, and each line in the grid has to be equal amount apart from each other. And then ordered pairs are written in the form x comma y, okay? Now, it consists of 4 quadrants, and they're labeled with Roman numerals. We start up here in the top right quadrant, that's called I, or quadrant 1, and then quadrant 2, II, quadrant 3, III, and quadrant 4, IB in Roman numerals. Lattice points are those that we can see as intersections on the grid line. So if I took a dot here and gave you, let's just, if I put a dot right there, you could say for sure, oh, sorry, apparently that dot will not just stay on the slide for me. I just have to hold it. If I had the dot there, you could say that that's the point 1, 1, okay? If I had the dot right here, you would tell me, hey, that's the point 4, 5. But if I had the dot, say, right here, okay, you know that it's -1, but you're guessing that it's somewhere between 5 and 6, okay? You don't know for sure. So that would not be considered a lattice point. A lattice point is the direct intersection of the horizontal and the vertical grid. So you know for sure what point that is, okay? All right, so slope. Slope refers to the steepness and direction of a line. It is the same as the rate of change concept that we learned in the previous lesson. Slope is denoted with an M. In our last lesson, we looked at the following: the rate of change, that's what ROC stands for there. The rate of change is the change in the dependent variable divided by the change in the independent variable, remembering that dependent was your y and independent was your x, okay? To get that change, though, you needed to find 2 points and subtract them from each other, right? So that's where the slope formula kind of builds from here. So calculate the rate of change for a line that passes through the points 1, 3 and 6, 5. In the last lesson, we talked about to get rate of change, we needed the change in y. Well, the change in y, if I go from 3 to 5, 5 minus 3 is 2, okay? The change in x, well, it's same thing. Just remember, wherever I start, I have to start on the other guy. The change in x would go from 6 to 1, so that would be a change of 5. So I would say that the rate of change is 2/5, okay? Now that should feel really familiar just based on what we did in the last lesson. Okay, so now what we're going to do is we're going to assign them x and y's, okay? We have 2 different points, so somehow we need to distinguish the fact that there's an x on this point and there's an x on this point. So what we're going to do is we're going to call one of them x1 and the other x2, just to distinguish that they're 2 different x values, okay? So look what happens when we do that. So here's my points again. We've already figured out the rate of change. The rate of change is 2/5, so I've written that there for our kind of remembering. So on this first point here, I'm going to call this x1, y1, okay? So I'm just going to say it's the x and y of 1 point. And then to distinguish it from this point, it's still x and y, but I'm going to call it x2, y2, okay? Now, we're going to do the same thing we just did. When we calculated the rate of change, we went, I just want to put my ink back on here. We went 5 minus 3. Well, that was y2 minus y1. And then we divided it by 6 minus 1, which was x2 over x1. So if we just put those labels into a formula, we are actually looking at this now, y2 minus y1 over x2 minus x1. Now, this is the slope formula, okay? And this would be given to you on a formula sheet. M equals y2 minus y1 over x2 minus x1. This, just so that you understand, this little triangle in math is the Greek letter delta, and so we would say delta y over delta x when we were reading that. And delta is a short symbol for change in, so we'd say the change in y over the change in x, okay? All right. Now, this is your, this is given to you on your formula sheet. So now we want to look at a graph with these 2 points and see if we can calculate the slope from the graph, okay? So I'm going to just take these 2 points, same 2 points that I've been working with so far, 1, 3 and 6, 5, and we're going to plot them on a graph, okay? So 1, 3 is right there, and 6, 5 is right there. Now, how do I go from one point to the next? We already know that this forms a line, okay? How do I go from this point to this point? Well, I want you to look at this really carefully. I would go up 2 and right 1, 2, 3, 4, 5. Up 2 and right 5. Okay, but look at what the rate of change is. 2 over 5. So I'm going up 2, that's represented by this 2 right here. That is the change in y. And I'm going over 5, that is represented by the 5 here. That's the change in x. Okay, so another way that we talk about slope when we're looking at a graph is we would say it's the rise over the run. Okay, the rise refers to the movement of my vertical, and then the run refers to the movement of my horizontal. Okay. Okay, so the up-down portion is referred to our rise, and the left-right portion is referred to our run. So slope can be looked at in all 3 of these ways, okay? We say the change in y over the change in x, or delta y over delta x, or we say rise over run, or we use the slope formula, y2 minus y1 over x2 minus x1. This is the only thing you're going to see on a formula sheet. You're not going to see these guys on a formula sheet, but helpful to know, okay? All right, so sketch the graph that passes through the point 2, -3 and has a slope of -2. Well, where do I start? I start with the point that I was given. I know 2, -3 is a lattice point. 2, -3, I can plot it right there. Okay, and now I apply the slope. Now it's important to realize I apply the slope from that point because that point has to be on the line. So from that point, I have to apply a slope of -2. Now, you always want to think about slope as a fraction here because you want to think about rise over run. So -2 as a number would be -2 over 1. Okay, so what that means is I have a rise of -2 and a run of +1, or I have a rise of +2 and a run of -1. Doesn't matter, but one of those has to be negative, okay? So if I do that, that means I could go up 2 and back 1. That would be a rise of +2 and a run of -1. Or I could go down 2 and right 1. That would be a rise of -2 and a run of +1. Okay, and if I did that for both of those points, I want you to see that those 3 points would connect in a line. Okay, and then the line would look like this. So see, I went up 2, back 1, or I went down 2, right 1, and they both end up back on this line. Okay. Okay, so now we're going to practice using the slope formula. I put it up at the top there, y2 minus y1 over x2 minus x1. The one thing you have to be super careful of here is just that you don't get your negatives messed up, because if you're subtracting a negative number, remember that that's like adding the positive, right? Okay, so probably pause me and try the first one. Okay, so for the first one, you should have ended up going 4 minus -2, that's a change in y, over 7 minus -3, that's the change in x. So 4 minus negative 2 is 6, 7 minus negative 3 is 10. You always want to leave it as a fraction. Don't you dare write this as a decimal, okay? Leave it as a fraction, but then you do want to reduce it as well. So 6 over 10 would reduce to 3 over 5. So this guy is the slope of 3 over 5. Pause me and try the next one. Okay, so same setup. You're going to go negative 3, subtract 5, and you're going to go 4, subtract negative 2. Now, you may look at this and you may say, oh, I did it the other way. That's totally fine. I chose to start by going negative 3 minus 5. You could have started by going 5 minus negative 3. That would have been totally okay as long as you did the same order in your x's. So if you started with the 5 here on top, you'd have to start with the negative 2 on the bottom and go negative 2 minus 4. That's going to get you the exact same answer that I got, okay? And that answer, as you can see, is negative 4 over 3 when I reduce. Okay, pause me and try the next one. So this one was a little different because you end up with 4 minus 4 on the top, which is 0 divided by something, and anything divided by 0 is 0. Now try the last guy. This guy was even cooler because you get 0 on the bottom. And what you need to realize is 0 on the bottom is a no-go. You can't divide by 0. You can't take something and divide it into equal parts of nothing. So anything divided by 0 is undefined. And what that means is you have to actually write undefined. Okay, that is your answer. There's no number that you can write here. There's no answer. So we say undefined. Okay, now I've given you actually 4 different cases of slope here. The blue one here is a positive slope, the purple is a negative slope, the pink is a slope of 0, and the green is an undefined slope. And I want to walk you through what each of these slopes look like visually. Okay, so the 4 cases of slope, m is greater than 0, that means it's positive. Okay, so when it's greater than 0, all graphs are read from left to right. So reading this from left to right, you'll see that the line is going up. Okay. When m is less than 0, that means I'm negative. Reading from left to right, you'll see a line going down. And then when m is 0, you'll see a horizontal line. And when m is undefined, you'll see a vertical line. Okay, so those are the 4 cases for slope that you would want to get super comfortable with. Okay, find the slope of each line graphically. Choose 2 clear points that are on the line and just count how much you have to go up or down, and then count how much you have to go left or right. Remember that the amount you go up or down is your rise, so that's on top, and the amount you go left or right is your run, so that's on the bottom. So rise is the number of units you go up or down. If you're going up, it's positive. If you're going down, it's negative. And then your run is the number of units you move left or right. If you're going right, it's positive. If you're going left, it's negative. And a reminder that if you went, let's say you went down and to the left, okay? That's a negative and a negative. Think about that as a fraction. A negative divided by a negative is a positive. So that's actually going to give you a positive slope. Okay. So if you have 1 negative movement, that'll give you a negative slope. If you have 2 positive movements or 2 negative movements, that will give you a positive slope. Okay. All right. So find the slope of each line graphically. Well, part of me would just like you to be comfortable before we even find it to say your answer does have to be a positive here, because when you look at this line, reading from left to right, this line is going up, and that would be a positive slope. Okay, so you find 2 points. Those are the 2 points I chose. How do I go from one point to the other point? I go up 1 over 2. So rise over run, my slope is 1 over 2. Okay. Next guy, I would want you to look at this and say this has to be a negative slope. Okay. Find 2 points that you're super comfortable with. Those are the 2 I chose. I'm going down 2, right 3. So my slope would be negative 2 over 3. Rise over run. Okay. All right. Find the slope of the line with an x-intercept of 11 and a y-intercept of negative 14. Anytime you're given an x-intercept and a y-intercept, that's just a fancy way of saying this point and this point. Remember, we've already talked about x-intercepts and y-intercepts, and that they're actually coordinate points. They're points that you could plot on a Cartesian plane. So an x-intercept of 11 is the point 11, 0. And a y-intercept of negative 14 is the point 0, negative 14. Okay, so those are my 2 points I have. Call one x1, y1, and call the other x2, y2, and then you can just apply your slope formula. Okay, so I went negative 14 minus 0 and 0 minus 11. Okay, so that gives me negative 14 over negative 11. Don't try and do these in your head either. Make sure you write the point, because if you don't write out the points and apply it to your slope formula, what happens is lots of kids will just look at those two numbers and they assume it's negative 11 over 14 instead of positive 14 over 11. Sorry, they assume it's negative 14 over 11 because they just take the y and they take the x, okay? But what I want you to notice here is when we actually set it up and use the formula, you get negative 14 over negative 11, which actually makes that positive 14 over 11, okay? Don't ever leave your answer with two negatives. A negative divided by a negative is positive. So if you left your answer here, I would take off marks because you didn't simplify. It's just like you didn't reduce the fraction, okay? So your final answer here should be 14 over 11. Okay, the slope of a line segment is 3 over 4. So this time we were given the slope. The line segment has endpoints 9, 10, and x, 4. Determine the value of x. So all we're going to do is we're going to set this up in the slope formula. We know the slope formula would be y2 minus y1 over x2 minus x1. So I've gone 4 minus 10, that's my y2 minus y1. And I've gone x minus 9, that's my x2 minus x1. Okay, but this time I knew the slope, so I could set that slope formula equal to what I know the slope is. The slope is 3 over 4. So now when I look at this, my algebraic skills have to kick in because now I need to try and solve for what x has to be in this situation. Okay, so what I'm going to do is I'm going to get rid of the division of 4 by multiplying both sides by 4. That's the first thing I'll do. Okay, so that gives me 3 equals negative 24 over x minus 9. Now I want to get rid of that division of x minus 9 so that I don't have a fraction there anymore. So I'll multiply both sides by x minus 9, and that gives me 3 bracket x minus 9 equals negative 24. I could now divide both sides by 3 and add the 9, or I could distribute the 3 and then solve that way. It doesn't really matter which one you do. Okay, I distributed the 3, then I'm going to add 27 and divide by 3, and I get x equals 1. So my missing number here is 1. Had you, at this stage here, just said, I'm going to divide both sides by 3, that's cool. You would have gotten x minus 9 equals negative 8, and then you would have added 9 to both sides, and you still would have gotten 1. Okay, so it doesn't really matter which operation you choose there. Okay, so that is a brief introduction on slope. There's some homework for you to try, and if you have any questions, you can connect with me. Okay, have fun, guys.